For my video project, I got assigned to do topic 12, which is integration and differentiation. At this point in the year, we have only used discrete analysis, which is points on an XY coordinate grid that are scattered all over the place. In topic 12, we learn about something MATLAB has to offer. MATLAB offers a symbolic toolbox, which allows for continuous analytical functions. In this picture you can see that it offers the same data as the graph for discrete data, but it's more fluid and flowing, and it's not as sharp around the edges. Like I said before, MATLAB offers a symbolic toolbox which allows for continuous analytical functions. It also offers many intrinsic functions. The first one is SYMS, and then the variable. SYMS is the call to make a variable symbolic. Symbolic variables are important because they allow the function to work with strings. When plugging in a symbolic variable into a function, such as f equals sine of 2x, f then becomes symbolic as well. For example, you have f of x equals sine of 2x. The third part of the intrinsic functions the symbolic toolbox has to offer is DEFF, parenthesis, f comma x, end parenthesis. This takes the derivative with respect to x. The fourth part about the intrinsic functions the symbolic toolbox offers is INT, parenthesis, f comma x, end parenthesis. This takes the integral of f with respect to x. There are three different methods for differentiation on MATLAB. One of them is forward. Forward uses next point for differentiation. It uses the equation f of I prime is equal to f of I plus 1 minus f of I all over x of I plus 1 minus x of I. The second method is backwards. Backwards uses the previous point for differentiation. It uses the equation f of I prime is equal to f of I minus f of I minus 1 all over x of I minus x of I minus 1. The third is central. Central uses both neighboring points. It uses the equation f of I prime is equal to f of I plus 1 minus f of I minus 1 all over x of I plus 1 minus xi minus 1. There are two different types of numerical integration. The first is analytical integrals. It uses the equation I is equal to the integral from a to b of f of x dx. This symbolizes the area under the curve method. The second is numerical integrals. It uses the equation I is equal to the sum of all i's times wi f of I, where w is equal to the weight and f is equal to the data. This method approximates the integral with a weight sum of discrete points.